Assalamu alaikum wa rahmatullahi wa barakatuh. This is to welcome you to the next edition of our online class. Today, inshallah, we are going to look at solution to selected past examination questions as we started during the previous lesson. And the area we are looking at today is chemical combination and chemical bonding. But as we did during the last class, we are going to start with introduction to the concepts. Now, chemical bond. A bond is a force holding atoms together in a molecule or a compound. And there are different types of bond. But among the different types of bond, the two most important ones are electrovalent, otherwise called ionic bond, and covalent bond. There are other types of bonds which include coordinate covalent bond, which is also called dative bond, hydrogen bond, Vander Waals forces, and metallic bond. Let's look at each of the bonds one after the other. Electrovalent or ionic bond. This is a bond that usually occurs between a metal and a non-metal. The metal usually donates electrons from its outermost shell to the outermost shell of a non-metal. And you know, when a metal releases electrons, it means the number of electrons in its atom has reduced, making it positively charged because it now has more protons than electrons. So the metal becomes metal ion, which is cation, positively charged. And when a non-metal gains electron, it now has more electrons than protons, which makes it to be negatively charged, and that is an anion. The force of attraction holding a cation and an anion together makes the bond between them to be very strong, and that is a strong electrostatic force. Then this type of bond are easily formed between a metal that has low ionization energy and a non-metal that has high electron affinity. Low ionization energy makes a metal to be highly reactive, and high electron affinity makes a non-metal to be very reactive. So a very reactive metal and a very reactive non-metal can easily form ionic bond. Next are the features of electrovalent or ionic compounds. Electrovalent or ionic compounds are the compounds formed by electrovalency, and they are usually solid at room temperature with high boiling points and high melting points. They are made up of ions that are joined together by strong electrostatic force, and they are usually soluble in water or other polar solvents, but not soluble in non-polar solvents. Their solutions or molten form usually conduct electricity. So these are the features or properties of electrovalent compounds. Next are the covalent compounds. The covalent bond. The covalent bond is formed between non-metals, and for the covalent bond to be favored between non-metals, the non-metals should have comparable or similar electronegativities. Remember, electronegativity is the ability of an atom to attract electrons to itself in a molecule. So if they have similar electronegativity, it means no atom will attract electron to itself at the detriment of the other atom. And when covalent bonding occurs, the molecules are usually resorted to, and these molecules occur discretely. They are joined together by weak forces of attraction, another force of attraction, which will be an intermolecular force that we are going to talk about very soon. But it's also possible for covalent bond to exist between an atom that has higher electronegativity than another atom. That is, for the two participating atoms to have different electronegativities. But when that happens, the molecule that will be formed will not be non-polar, it will be polar, because the one that has higher electronegativity will tend to be negatively charged, while the one that has lower electronegativity will tend to be positively charged. So there will be partial charge, and that will lead to partial polarity, to the extent that when the molecule gets into water, it would be soluble in water. And that's why we have some covalent molecules that are soluble, even though covalent compounds are not expected to be soluble, as you can see in the features highlighted on your screen now, that the covalent compounds are usually solid with low melting points, or liquid with low boiling point, or gases at room temperature. It can be any of these. If they are solid, their melting points will be low. If they are liquid, their boiling points will be low, or they would be gases. So low boiling points are also called volatile liquids. So mostly covalent compounds, when they are in liquid state, are volatile. Now, they are also made up of discrete molecules that are joined together by weak van der Waals forces, or weak forces of attraction, and they are usually insoluble in water or polar solvents, but they dissolve easily in non-polar solvents. They do not conduct electricity when in solution or in molten form. Now, there's another form of attraction that occurs between covalent molecules. That is, when the atoms have already joined together by covalent bond. The molecules, one molecule joined to another molecule. So that's what that type of bond is called intermolecular force. So dipole attraction occurs when you have a polar molecule joined to another polar molecule. I have told you, if the electronegativities are not equal, the molecule will tend to have partial positive and negative charge. So the first holding the partially negatively charged part of a molecule to the partially positively charged of the next molecule is what we call dipole attraction. And it occurs in molecules like hydrogen chloride. You can see both of them are non-metals, but the electronegativity of chlorine is much higher than that of hydrogen. Like carbon dioxide, both carbon and oxygen are non-metals, but the electronegativity of oxygen is much higher than that of carbon, and so on like that. Dative bond. Dative bond occurs between a molecule that has lone pair electrons and another atom or ion that requires electron. So the other atom or ion that requires electron will share one of the lone pair electrons of the molecule, and that is actually what happens in water. If you look at this bond, this is bond between hydrogen atom, this is an hydrogen atom, this is another hydrogen atom bonded to an oxygen atom, making H2O. This is the way a molecule of water appears. Now these atoms and these electrons are called bond pair electrons because they are shared between the two atoms. These ones are also called bond pair electrons. The electrons that are not used in bonding are called lone electrons, and we group them into two. So we say lone pair electrons. There are two lone pair electrons here. For example, you have 4 electrons that are not used in bonding, so you have two. You call them two lone pair electrons. Since water molecule has two lone pair electrons, it means it can still bond with another atom or ion that requires electrons, and that's what happens here. So it bonds with hydrogen ion, and this hydrogen ion will share one of the lone pair electrons, and that will return to hydroxonium ion, which is H3O+. So that type of arrangement is what we call dative bonding, and the first holding them together is called dative bond or coordinate covalent bond. The next one is hydrogen bond. Hydrogen bond is also is not a true bond as well, because we have defined bond as first holding atoms together. So when we are talking about hydrogen bond, we are talking about if a force that is holding molecules together. So it does not fit into the definition of bond. So that's why it says it's not a true bond, but it is rather an intermolecular force. It occurs when a covalent bond has been formed between a highly electronegative element and hydrogen. For example, hydrogen fluoride. The bond holding hydrogen to fluorine, hydrogen fluoride, is covalent bond. But fluorine is much more electronegative than hydrogen. So this imparts negative charge on fluorine, positive charge on hydrogen. So it makes hydrogen fluoride to be attracted to another hydrogen fluoride molecule. So the force holding one hydrogen fluoride to another hydrogen fluoride molecule is hydrogen bond. The same thing occurs in water, H2O, and the same thing occurs in ammonia, NH3. So for a molecule to be qualified to participate in hydrogen bond, there are criteria that it has to meet. Number one, it must be made up of hydrogen, and the other atom must be a highly electronegative element. The three common examples among the non-inorganic compounds are hydrogen fluoride, ammonia, and water molecules. And we also know the properties of the molecules that exhibit hydrogen bonding. They are usually liquid with high boiling points. They are soluble in water. They exhibit dimerization. Metallic bond. This one is the force holding metal atoms together. How does it occur? It occurs when metal atoms donate electrons to an electron cloud. Electrons are negatively charged. A metal atom that has donated electron will be positively charged. The force of attraction between the electron cloud, which is negatively charged, and the metal ions, which are positively charged, result into a very strong substance, which we call metal. And this is why metals are usually strong. Van der Waals forces. Van der Waals forces is also an intermolecular force. It's not a true force as well. It occurs between polar covalent molecules. Remember, both hydrogen bond and dipole attraction that we have mentioned before occur among non-polar covalent compounds. Occur among polar covalent compounds. Both hydrogen bond and dipole attraction occur among polar covalent compounds. But van der Waals forces occur among non-polar covalent molecules. So when a molecule has been formed by covalent bond, and the electronegativity of the molecules concerned are comparable or are the same, such molecules will be attracted to each other, will be bonded to each other by van der Waals force. And that's why van der Waals force is very weak, because there are no oppositely charged ions that will bond them together permanently. So covalent compounds that are bonded together by van der Waals forces are usually gases, and this type of force is found in molecules of the same element, like oxygen molecule, hydrogen molecule, iodine molecule, chlorine molecule, even molecules of noble gases. They have van der Waals forces holding them together. Now, coming to the questions, after a brief look at the background knowledge as we have just done. Now, the first question here is: a white solid substance with high boiling point and high melting point is likely to be a covalent compound? No. Covalent compounds are supposed to have low boiling point or low melting point, as we have discussed. Dative covalent compounds? No. Dative covalent compounds are covalent. They are covalent compounds in themselves. Electrovalent compound, that's the correct thing. Non-metal, no. Next question. How many lone pair electrons are in hydrogen fluoride molecule? If you look at the structure of the fluorine molecule, it has 7 electrons in the atom shell. Look at the structure of hydrogen molecule, hydrogen atom. It has 1 electron in the atom shell. By the time a hydrogen atom bonds with a fluorine atom will donate 1 electron to the bond. While hydrogen also donates 1 electron. The 2 electrons will be shared between them. It means fluorine atom shell will be left with 6 electrons, and 6 electrons group in pairs will form 3 pairs. So we have 3 lone pair electrons. So the correct answer to that question is 3 lone pair electrons, was option D. Next question. Which of the following substances is non-polar? Non-polar, that is, will not have that, where you have molecules, a molecule that one of the atom does not become positively charged and the other one does not become negatively charged. That is, it will not eventually be charged. Let's look at them one by one. You have bromine. Bromine molecule is made up of 1 bromine atom and 1 bromine atom. So they have equal electronegativities. So it is non-polar. Ammonia. Ammonia is made up of nitrogen and hydrogen. Nitrogen is electronegative compared to hydrogen, so it is polar. Water, H2O. Hydrogen has low electronegativity compared to oxygen, so it is polar. Hydrogen bromide, there is significant difference between electronegativity of hydrogen and bromine, so it is polar. So the only one that is not polar there is bromine molecule. Next question. Which of the following compounds has coordinate bond in its structure? So if you look at aluminum chloride, even though it is made up of metal and non-metal, it is essential. It is made up of coordinate covalent bond. Magnesium chloride is significantly electrovalent. Silver chloride is significantly electrovalent, while sodium chloride is highly electrovalent as well. So it is aluminum chloride here. Next, in which of the following compounds does hydrogen form ionic compound? A, you have 2 non-metals, so both of them are non-metals. That is CH4, methane, so it is covalent. Hydrogen chloride, covalent. Ammonia NH3 is covalent. Sodium iodide is made up of metal and non-metal, that is electrovalent. So that is option D. Next question. The strength of metallic bond depends on the charge density of the atom, ductility of the metal, number of valence electrons, total number of electrons in the atom. So it is number of valence electrons, because it is the atom's electron that will be donated into the electron cloud. So the more the electron cloud, the higher the number of electrons in the electron cloud, the stronger the attractive force and the stronger the metallic bond. So it is number of valence electrons. Now, next question. Solubility of carbon dioxide in water can be accounted for by, you can see carbon dioxide is made up of carbon and oxygen, and there is significant difference in the electronegativity. So carbon dioxide is polar, so, and that is as a result of the dipole attraction between one carbon dioxide molecule and the next carbon dioxide molecule, and that is option C. Next question. Which of the following would not influence electrovalent bond formation? Electronegativity, that is ability of an atom to attract electron to itself in a molecule. Electron affinity, that is ability of an atom to attract electron to itself in isolated gaseous state. Ionization potential, ability of an atom to lose the atom's electron in its isolated gaseous state. Catalytic ability, you will recollect that we said that low ionization energy and high electron affinity favor electrovalent bonding, and the higher the electron affinity, the higher the electronegativity as well. So they are related, but catalytic ability does not have anything to do with the question, so that should be the correct answer. That's option D. Now, next question. Which of the following substances does not have van der Waals forces? Copper, graphite, neon, iodine. All of them are non-metals except copper. So copper has metallic bond, and that's the correct answer. If you look at iodine crystals, it is van der Waals forces that are holding the molecules together. If you look at neon, it is van der Waals forces that are holding the atoms together. If you look at graphite, even though graphite is made up of the layers, so the first layer for atoms of carbon in each layer are held together by covalent bond, but between one layer and the other, the force holding the atoms together is van der Waals force, and that's why graphite flakes. Next question: which of the following is correct? So the correct answer to that question is copper. It is the only one that does not have van der Waals force. So the next question here is: which of the following is correct? Covalent compounds will readily ionize in water. Wrong, because we know that covalent compounds do not ionize at all. Covalent compounds consist of ions. Wrong, they are not made up of ions, they are made up of molecules. Hydrogen bond is formed between a metal and a non-metal. No, hydrogen bond is not even formed between atoms. It is formed between molecules. So, and a metal is an atom, a non-metal is an atom. Now, next question. The next option: ionic compound in solution will conduct electricity. That is correct. That's one of the features of ionic compounds that we have just mentioned, because they are made up of ions. So when they dissolve in water, the ions are separated, and the ions are also carriers of electron. Next, potassium chloride does not conduct electricity in the solid state because it is a covalent compound. No, potassium chloride is not covalent. Strong cohesive forces make its ions immobile. Yes, it is made up of ions, but since we have chloride ion and potassium ion joined together by strong cohesive force, the ions are immobile, so they cannot. So we have to mobilize the ions before they can conduct electricity, and the way to mobilize the ions by dissolving it in water or by melting it. Now let's look at the next other options and why they are wrong. Strong cohesive forces make the molecules mobile. No, the word molecule here has made this option irrelevant, because it is potassium chloride is not made up of molecules, rather it is made up of ions. Now let's look at option D. Each potassium and chloride ion has noble gaseous structure. No, that's not the correct answer. Now let's go to the next question. When an element Y atomic number 20 combines with another element Z atomic number 8, what happens? Now look at this. Y having atomic number 20, we have electronic configuration of 2882, and that is a beta. It means the valency is 2. Z having atomic number of 8, we have electronic configuration of 26, and that means the electronic configuration will be 26 and the valency will be 2. So both of them have 2 as valencies. So when they combine, one atom of each will require one atom of the other. So it should be YZ, and the convention is that the metal should be written before the non-metal. That is the one that has electrons to spare should be written before the one that gains electron. So it should be YZ, and it's going to be because we have a metal and non-metal, it's going to be an electrovalent compound. So let's look at the options. Equivalent compound, YZ is formed. Wrong, because this word covalent makes it wrong. Option B, equivalent compound, ZY is wrong. No, both word covalent and the arrangement of the atoms makes this one to be wrong. Next is ionic compound, YZ is formed. Yes, that's correct. It's ionic or electrovalent, and it should be YZ because Y is a metal, Z is a non-metal. So metal non-metal is the convention. So option D, an ionic compound, ZY is formed. What makes it wrong here is because Z is written before Y. So this is wrong. So the correct answer to this question is option C, ionic compound YZ is formed. And that is not because Y comes before Z in a alphabetical order, but because Y in this case is a metal. So you have to look out for which one is metal and write it before you write the non-metal. So next question. The bond formed between water and hydrogen ion to form hydrogen ion is what? So it's one of the examples that we gave as dative bond. So it cannot be covalent because it's not between metals and a non-metal and a non-metal. It cannot be electrovalent because it's not between an atom and an atom. It's this between a molecule and ion. And it cannot be ionic. Ionic is dangerous electrovalent. So this option C and option D are essentially the same. So next question. The compound formed between X14 and Y16 is, so you write the electronic configuration of X, that is 284, meaning that valency is 4. Electronic configuration of Y286. The valency is 2. So to join them together, you have X2Y4 or XY2. Both of them are non-metals. So XY2, and Y is more electronegative than X. If you look at the way they will be in the periodic table, so Y is more electronegative than. So because this one is in group 6, this one is in group 4. So it means X should be written first. So XY is wrong. XY2 is correct. X2Y is wrong. And X2Y6 is wrong. So the correct answer is option B. Now next question. Which of the following oxides is ionic? Option A, P4O10. That is non-metal and non-metal. So it's covalent. MgO, yes, that's metal and non-metal. So it's correct. Al2O3, I've told you that aluminum oxide is essentially dative. S2O, no, that's ionic. So that's covalent. So the only one that's ionic here is magnesium oxide, which is option B. So with that, we have come to the end of today's class, and I pray that Allah grants you understanding. Assalamu alaikum warahmatullahi wabarakatuh.